Okay, I'm going to show you some things of how to do some light calculations. So you saw some light things in some of your packets. We worked a little bit with it with the spreadsheet. And now we're going to go a little further into that. So you may remember from the packet on light and electron structure that the speed of light is 3 times 10 to the 8th meters per second. This worksheet that I'm using is available for you to print, or if you don't have the ability to print, there is a place to annotate it. So I know that'll be a little tougher. Do the best you can with this, or if you just want to write it on a piece of paper. Whatever we can do to get you through this is fine. So if you scroll down, you will see that there is a place to write the equation. So the equation for the relationship between light is that the speed of light equals the frequency wavelength times the frequency. You should have seen in your book this equation. This is the Greek letter lambda, and this is the Greek letter nu. Okay, so the speed of light is measured in meters per second. You'll hear length in wavelength, so that is meters. And then if you look, what we have to have in order to get meters per second here is 1 over seconds. So frequency is 1 over seconds. It's also called a hertz. So you may have seen on a radio station, when you dial it in, you're doing 105.7. That's actually megahertz, so that's the frequency of which they're broadcasting. That's how you're picking up that wavelength. So the other thing that you may see for it, I guess I should capitalize it, you also may see seconds to the -1, which is the same as 1 over second. So any of those units will be used. Sometimes you'll see waves per second. Again, all of those are for frequency. Sometimes you'll see meters per wave for wavelength, but most of the time the waves are dropped, but that's truly how the units work out. Okay. So again, this is a lot like gas laws. You're just plugging in. So if I know the speed of light, I'm going to plug that in. And I want to know the wavelength. So lambda is what I don't know. Do the best you can with making that little Greek letter. And 4.57 times 10 to the 14th waves per second. Okay. Just algebra from there. Again, this is the minimum you need to show. If you are good with your algebra steps, you don't need to show any more of that. If you do need to show the algebra, if that helps you, you certainly can do that, but that is not required. But again, I'm just going to go through that for this one for those of you that like to see the algebra. Okay, and you'll see seconds cancel, and you're really left with wavelength in meters per second. Okay, just remember when you're putting this into the calculator, you're going to do 3. Again, most of you use that other calculator where you're going to have to hit second EE. My calculator, I don't have to do that. That's one of the things I like about this other version of the calculator. And then divided by 4.57, again, second EE for most of you, 14, and equals. So again, sig figs count. Speed of light is known to a lot more digits, so we're limiting you to 3 based on that. So our final answer will be 3 sig figs, so it's going to be 6.56. And that's not right. Let me clear that again. Let me try that again. 3 EE8 divided by 4.57 EE14. Okay, again, if it gives you this, make sure you're putting it to scientific notation. So again, depends on the calculator. Okay, so 6.56 times 10 to the -7th, and that would be meters or meters per wave. Okay. Okay, next one, again, I have a wavelength of 4.86 times 10 to the -7th. You'll see that's a very common number, so you'll see that exponent's the same. So visible light falls in that area. and I'm finding wavelength. So again, some people, if you don't like to do the algebra that way, some people will solve the equation for the variable and then plug in. So I'm trying to find frequency, so this is what I need to know. So I have to divide both sides by wavelength. So this is another option for doing these problems. And then I'm going to divide by the 4.86 times 10 to the negative 7th meters per wave. Okay, your meters will cancel. So this gives you units of 1/seconds divided by 1/waves. So when you do your algebra here, when you divide by a fraction, you multiply by the reciprocal. So that's how we end up with waves per second for the unit. And again, you likely won't see that. Okay. And again, if I try to enter this one in the calculator, it's going to be 3EE8. And again, most of you, it's second divided by 4.86. Remember, you're not entering the times or the 10. The EE is taking care of that. Okay. And this one, because it's such a large number, is automatically defaulting to scientific notation. So this will be 6.17 times 10 to the 14th. Again, notice that exponent matches what we had up here. Again, frequency for visible light. And I'm just going to do 1/seconds. But again, it could be waves per second, or hertz, or seconds to the -1. So again, I'm not sure why there's so much variety with those, but those are all ones that you're going to see. Okay. All right. I'm going to pause the video here. I am going to put a place for you to submit answers. So I'm going to let you try and solve the next two on the problems. So if you want to pause the video, I'm going to skip ahead to the next part.